Data sufficiency, question 257. If the sequence S has 300 terms, what is the 293rd term of S? So here we have a value data sufficiency where we need to find the 293rd term of a sequence of 300 terms. On the GMAT, whenever we speak about sequences, there are two types of sequences. The first is called an arithmetic progression and the second is called a geometric progression. When a sequence is an arithmetic progression, then the nth term is given by the formula a plus n minus 1 into d, where a is the first term, d is the common difference, and n is the number of terms. And if the sequence is a GP, then the nth term is given by the formula ar to the power of n minus 1, where a again here is the first term, r here is the common factor, and n is the number of terms. Now the question doesn't tell us which sequence we are dealing with. So it could either be an AP or a GP. But we need to find the 293rd term of the sequence, that is A of 293. Evaluating the first statement individually, the 298th term of S is minus 616, and each term of S after the first is 2 less than the preceding term. So clearly the first statement tells us that the sequence that we're dealing with is an arithmetic progression. And in an arithmetic progression, the nth term is given by a plus n minus 1 into d. So to find the 293rd term, a of 293 would be a plus 293 minus 1 into d. So to find a of 293, we need the value of a and we need the value of d. The first statement tells us the 298th term of S is minus 616. So a of 298 is a plus n minus 1 into d. So this is minus 616 is equal to a plus 298 minus 1, and d here is given to us as minus 2. So clearly from the information in the first statement, we can solve for a, we have a definite value for d, we can definitely get an answer for a of 293. So the first statement is sufficient and the two possible answer choices are AD. Remember, this is a data sufficiency. So you don't need to go ahead and solve for the value. You just need to see if the statement gives you enough information to solve. Now evaluating the second statement individually, the second statement tells us that the first term of S is minus 22. So we have A to be equal to minus 22. But the second statement individually does not tell us whether the sequence is an arithmetic progression or a geometric progression. So we can't make an assumption here that it is an arithmetic progression. So the second statement individually is insufficient, and the answer here is alpha. Now this question is a clear trap question where many students would take the information of the first statement and carry it over with the second. Remember, you should stay away from getting influenced from the first statement when you evaluate the second statement individually.